Alright, in this episode we'll talk shock absorbers and turn signals. I decided to upgrade my rear shocks. Up to this point I've been using the El Cheapo eBay kind. I think they usually go by the name of RFI. To be fair, I haven't really had any complaints with them, but due to the fact that I've spent 2 years up to this point building this bike, it feels kinda cheap not to go with a pair of name brand ones. The shocks I picked are by no means high-end. I think it's the YSS entry-level model, and you're able to order them in many different configurations to fit your particular bike without having to spend a fortune. Installing them, however, turned out to be quite problematic, since the lead designer of this project decided in all his wisdom to remove the central stand. This gave a very slight improvement of the power-to-weight ratio, but it had devastating consequences for the maintainability of this bike. So to avoid any heartbreaking whoopsies, I bought a front wheel stand and built a platform to secure the bike to. This so I could use questionable methods safely in order to get the back wheel off the ground. My original idea was to integrate the turn signals into the shock mounts, since they protrude from the frame anyway, and that would mean that I could keep the look of the bike pretty clean. But for that to look nice, I would have to fill the visual space between the shocks and the frame, or else there would be a kind of a strange void there. I plan to use some plastic tubing I had laying about and fabricate some bodywork to fit that gap. That is easier said than done though. The chassis have a complicated 3D geometry and you could spend hours upon hours adjusting until you get a perfect fit. However, I came up with what I thought was a pretty clever tool that allowed me to trace the cut line directly on the tube. And from there, I just had to cut out that shape and then adjust the length, and that part was done. The next logical step was to print the end cap that would serve as the indicator holder itself, and when I tried fitted everything on the bike, I didn't like the look of that at all. I had prototyped this idea using the RFI shocks, and they were much heavier visually. So with these newer, thinner and sleeker shocks, the idea simply didn't work, so I had to abandon it. This direction change forced me to repair the tapped holes I've drilled in the shock mounts. The idea of welding or soldering these holes didn't give me the warm fuzzies. Not only would it be very difficult, but it could also potentially do more harm than good. Instead, I cleaned the area well and used a bit of the green stuff, which is a great option if you want to permify something in metal. I gave it time to harden and then I slowly hacksawed away the end of the screw. If there is something that would be classified as the Achilles heel for Loctite, it would be heat. Then I could clean the end of the stud with a file and give it a lick of touch-up paint. I decided to put a pair of turn signals on the license plate instead. My logic here was that just like the indicators, the plate is something that is ugly and I might as well package them together. The riveting went kinda poorly. The expansion did not work correctly. I think it's because the hole was too big. The rivet I was using is a 4mm, and I drilled a 5mm hole, and it's supposed to be a 4.1. I googled this afterwards, of course. So I managed to screw up the length of the wiring. The right side needed to be a bit longer. I very cleverly color-coded the turn signal wiring based on lanterns or boats. The only problem is that I have no knowledge nor interest of seafaring, so I constantly mix them up. The torque spec for the shock fasteners kinda surprised me. It's an M10, so if I hadn't looked, I probably set my torque wrench about 40 Newton meters and called it good. But I checked the service manual and the torque spec is 20 to 30 Newton meters for these. It's easy to forget that the shock mounts once was a separate piece that was welded into the frame during manufacturing, and that piece is probably not made out of the same grade of metal as normal bolts are. On top of that, Suzuki used a fine thread here for this interface, and a smaller pitch gives you more leverage and you won't need as much torque to reach the same level of clamping force. And there we go. Thank you for watching. If you enjoyed the video, consider checking out the project playlist and see if you find something of interest. Have a good one.